So good evening all. Welcome to SAKALAVIDYA YouTube channel. Welcome to the evening session. Okay, Swati Singh, Madhurima, Asha, Jaya, Krishna Reddy, Hari Krishna, Nakshatra, Vinoda, Pranay, Conceptor, Balu, Chinta Vinoda, Ramya, Nevireddy, Chandana Sri, Nakshatramayi, Jakir Beg. Okay, right. Gishwank, Rohan. Okay. Vectors, after that I will complete it. Don't worry. Coordinate system, (3D) Part 1. So today's chapter is 3D coordinate system part 1. Okay, just we'll expect 1 or 2 marks from this chapter. 1 or 2 marks. Okay, Vaishnavi Vinayaki, Prasanna, Ashwin Kumar. Right, hi. Good evening all. Sumant. Okay, Raghunath. Vikas. Right. See, this is the actually space. In a space actually, for example, if you consider say this is x-axis, this is x dash, say this is y, this is y dash, say this is z dash, z, this is z dash. Now this is the origin. So this xo x dash, xo x dash, yo y dash, zo z dash are mutually perpendicular lines meet at origin. So that means actually the space will be divided by the x-axis. This is called x y z axis. They are called x y z axis, x-axis, y-axis and z-axis. So actually this is called now space. The space can be divided into how many compartments? Let us see now here. So what are the components? Compartments means actually here xy xoy component, xoz component and x dash oz component, x dash o dash z component, and also below also we shall get the components. Total we shall get 8 components, we shall get it. 8 compartments we shall get it. Each compartment called here actually octant. Each compartment is called octant. How many octants here we have? 8 octants we have. 8 octants. Understood now? For example, if you consider any point in this space, for example say p x comma y comma z, where x comma y comma z are real numbers. For example, real numbers. So in each compartment they have the signs, that means symbol, sign scheme. Sign, they follow sign scheme. So let us have a discussion on the sign scheme in the components. So that means total this coordinate axis divide the space into 8 equal parts. Each part is called octant. In each octant, what will be the coordinate of the point? So let us see. For example, if you say one point is x comma y comma z in the plane, so it will be divided into the all 8 components. So for example, now let us see what are the points now like this. Sign scheme you need to remember. Sign scheme means actually you see, you take it plus sign here and minus sign. Next write down here, again plus sign write down, here minus sign write down, here plus sign write down, minus sign write down. Next here plus sign write down, minus sign write down. Here also plus sign write down, minus sign write down. Here also plus sign write down, minus sign write down. Plus sign and minus sign. So that means the coordinates will be like this scheme. Sign scheme will be like this. So that means plus plus plus. All 3 coordinates will be plus plus plus. So that means this will be like this, x comma y comma z. All are positive. It may be one octant. Next it may be plus plus. Sorry, 1 minute. So this will be plus plus minus. So generally you get like this, x comma y comma minus z. Next we have plus minus plus minus plus. So generally we can write x comma minus y comma z. So next minus plus plus. This we can write minus x comma y comma z. This is minus plus minus. Minus x comma y comma minus z. Minus minus plus. This is minus x comma minus y comma z. Next we have all negative signs, minus minus minus. So minus x minus y minus z. See, in the space actually we have these combinations, x comma y comma z, x comma y comma minus z, x comma minus y comma z, minus x comma y comma z, minus x y comma minus z, minus x minus y comma z, minus x minus y z. Understood now? And one more thing actually, for example, if I ask one question to you, the number of octants, for example, one question read on here, the number of octants, number of octants in which x coordinates are positive. X coordinates are positive. For example, this question is asked. See, the number of octants in which x coordinates are positive. So x coordinates are positive means, right. So now that I will write, don't worry now. Yes, here also plus minus plus combination only. Plus minus minus. So x comma minus y comma minus z. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Total 8 octants. Okay. Number of octants in which x coordinates are positive means actually here see 1, 2, 3, 4. So 4. The number of octants in which x coordinates are positive means 4 only. In the similar manner, there may be one question. The number of octants in which y coordinates are positive, that is also 4. The number of octants in which z coordinates are positive, that is also 4. Answer. Understood now? So this is the basic concept we need to follow. So here you remember, in this x comma y comma z is called triad or triplet. This x is called x coordinate, y is called y coordinate, z is called z coordinate. Remember, just like in two-dimensional system we have x coordinate, y coordinate, only two coordinates. Here in 3D system we have three coordinates: x coordinate, y coordinate and z coordinate. Understood now? So symbols will be like this. You might have understood the sign scheme of the points in the different octants. Octants are nothing but called, they are compartment, just like room itself only. Each room, the 8 rooms are there. In that 8 rooms, the coordinate system, the sign scheme will be like this. Sign scheme we have discussed. Coordinates and as well as sign scheme. Sign scheme. Okay, you might have understood now. So next let us move to, for example, in the space, let us consider 2 points. Let px1 comma y1 comma z1 and q x2 comma y2 comma z2 be any 2 points in a space. Don't call plane, it's not a plane, it's a space. In a space, then PQ, distance between P point and Q point, PQ is given by, so you need to write x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So this is under root. This is the formula to find out distance. This is called distance formula. Distance formula. Distance formula. Just like in 2D system itself only. Next, the distance from origin to P of x comma y comma z is OP equals to root of, that will be x square plus y square plus z square. Understood now? The distance from origin to the any point in the space P x comma y comma z is OP is equal to, or OP bar, you can say no problem, OP root of x square plus y square plus z square. Okay, next now third point. Let us discuss third point. The coordinates of the point, the coordinates of the point which divides the line segment joining the points P of x1 comma y1, otherwise you can say a point, no problem, x1 comma y1 comma z1 and B x2 comma y2 comma z2 in the ratio m is to n is, say the coordinates are p equals, for example, that point mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n, mz2 plus nz1 by m plus n. Here m does not equal to minus n. You remember this condition. This is called, actually we name it as, this is section formula. Section formula. This is called section formula. Section formula. For example, when do we say that the P divides internally or externally, means accordingly the sign of m is to n. If the sign of m is to n is positive, then we say that the divides internally. If m is to n is negative, it divides externally itself only. Understood now? This is called section formula. Okay, next now we need to find out for example, fourth point is midpoint formula. The midpoint of the line segment joining the points a x1 comma y1 and b x2 comma y2. Midpoint, for example. Midpoint, for example, p equals to, we can write coordinates x1 plus x2 by 2 upon y1 plus y2 by 2 comma z1 plus z2 by 2. This is midpoint formula. Midpoint. Midpoint formula. This is called midpoint formula. Right, x1 plus x2 by 2 comma y1 plus y2 by 2 comma z1 plus z2 by 2. Okay, that's absolutely correct. Okay. Next one, so fifth concept. So for example, take a line segment. So this is a point, say that is a is x1 y1 z1, midpoint m, say that is alpha, beta, gamma, and next b coordinates we need to find out. What are the b coordinates? What are the b coordinates? For example, if m is the midpoint of line segment joining a x1 comma y1 comma z1 and b is m of alpha comma beta gamma gamma, then we need to find out next b coordinates. So that means actually we can write like this: m is equal to, we can write concept a plus b by 2. Use matrix concept, no problem. A plus b by 2. So now we get a plus b equals to, our vector concept also it is a plus b equals to 2m. Now we need to find out b. B equals to 2m minus a. That means we need to multiply the midpoint with 2 alpha comma beta comma gamma, minus we need to subtract x1 y1 z1, so that we get this equals to other end of the line segment also. We can write 2 alpha minus x1 comma 2 beta minus y1, 2 gamma minus z1. That's all. So in this way we can find out. So what's our doubt? Okay. Yes, absolutely correct. 2 alpha minus x1, 2 beta minus y1, 2 gamma minus z1. Okay, next now, sixth point we shall discuss point of trisection. Point of trisection. So let me discuss point of trisection. For example, it's a line segment, say A B. Let us divide this line segment into three equal parts. So this is the first part, second part, say like this. This is equal to this, this is equal to this. Say this point is P, this point is Q. So that means, you see, if AP equals to PQ is equal to QB, then P comma Q are called points of trisection. Points of trisection of line segment AB. So now we need to find out ratio. Ratio means, for example, see, this part is actually, you can say 1. This 1 plus 1 is 2. That means P divides AB in the ratio 1:2. You get the first point of intersection. If you want to find out Q, you see now this different color I will show with a different color. So don't worry, different color. Now AQ equal to two parts. This QB will be one part. Q divides AB in the ratio 2:1. So that we get actually here 2 points of intersection. That means P divides AB in the ratio 1:2. Q divides AB in the ratio 2:1. And one more interesting point I will tell you. Midpoint of AB is same as midpoint of PQ. That also one concept you will write it, very important point. Midpoint of AB equals to midpoint of PQ, where P comma Q are the points of trisection. If P comma Q are the points of trisection, then we can write a midpoint of AB is equal to midpoint of Q. So now, what are the P coordinates and what are the Q coordinates? P coordinates means actually here you can write, so 2A plus B by 3. This is the relation. Whereas Q coordinates is equal to A plus 2B by 3. Here P is called first point of intersection, Q is called second point of intersection. So that means whenever, if you want to find out first point of trisection P, you need to use this, make use of this formula. Second is this formula. This can be formulated if A comma B are given x1 comma y1 comma z1 and B given x2 comma y2 comma z. Easily we can find out. Don't worry, with the help of this we can find out. So this is about the actually point of point of trisection or trisectional points that we have discussed. Now the seventh point. The centroid of the triangle formed by the points A x1 comma y1 comma z1, B x2 y2 z2, and C x3 y3 z3 is G equals to, we can write x1 plus x2 plus x3 by 3, that means mean of the x coordinates comma mean of the y coordinates. So y1 plus y2 plus y3 upon 3, z1 plus z2 plus z3, okay, or this we can write like this also. This we can write sigma xi I is equal to 1 to 3 by 3 comma sigma yi I is equal to 1 to 3 by 3 comma sigma zi I is equal to 1 to 3 by 3. Understood now? For example, if you take triangle ABC, this is triangle ABC for example. In vector notation also we can find out ABC. This is the centroid, means point of concurrence of the medians. Here D is the midpoint of BC. For example, E is the midpoint of CA, F is the midpoint of AB. So you join BE, you join CF. They are concurrent at this point. This point is called centroid. This point is called centroid. G divides AD in the ratio 2:1. Here also same 2:1, 2:1 ratio. So now this can be remembered like this. G is equal to vector form. For example, position vector of A is A, position vector of B is B, position vector of C is C, position vector of G is given by A plus B plus C by 3. Or we can remember like this also. A plus B plus C is equal to 3G, 3 times centroid. You remember like this also. Just check it. 1 minute, I will come. Next point, let us discuss next point. Eighth point. Suppose in triangle ABC, A, B, C, A vertices are x1 comma y1 comma z1, and next the B vertices are x2 y2 z2. C vertices we do not know. Centroid of triangle ABC is G, where G is equal to alpha comma beta comma gamma. Then we need to find out C. How to find out? Yes, now we can find out. So we know that already we had a discussion. A plus B plus C equals to 3G. Now C is equal to, third vertex is equal to 3G minus of A plus B. So that means 3 times centroid, that is 3 times alpha comma beta comma gamma minus of sum of these two vertices, That means just like a vector components only there also. So that means we can write x1 plus x2 comma y1 plus y2 comma z1 plus z2. So this equals to, we can write 3 alpha minus x1 minus x2 comma 3 beta minus y1 minus y2 comma 3 gamma minus z1 minus z2. This formula can be used when two of the vertices of the triangle are given and next its centroid is given. Easily third vertex we can evaluate with the help of this concept. Okay, now so next concept. Let a x1 comma y1 comma z1 b x2 comma y2 comma z2 c x3 comma y3 comma z3 and d sorry wait are the be the vertices of a parallelogram then fourth vertex D, say for example D equals to. So this is the concept we need to find out. If the three of the vertices of a parallelogram are rhombus or square or a rectangle are being given, then how to find out the fourth vertex? Its fourth vertex we need to find out. Thank you. So now actually let us move to diagram wise right now. Okay, suppose now if you want to find out let us say A point, A vertex, this is B vertex, this is C vertex, this is D vertex. Say here A vertices are given x1 comma y1 comma z1, B vertices are given, this is x2 y2 z2, C vertices are given, this is x3 y3 z3. So now okay, right. So now we need to find out D vertex. We need to find out. Here see For example, this is the point of intersection of the diagonals, AC diagonal and BD diagonal. For example, say this is P. P is the midpoint of AC. P is the midpoint of BD also. For example, let us say this is alpha, beta, gamma. So we have one concept. What is the concept means actually here? Midpoint of AC equals to midpoint of BD. Midpoint of BD. So midpoint of AC means A plus C by 2 equals to midpoint of BD is B plus D by 2. So 2 gets cancelled. We have A plus C is equal to B plus D. We need to find out D. So D equals to, very simple manner we can write A plus C minus B. That's all. A plus C minus B. So that means if you want to find out D, add A and C, subtract B. If you want to find out A, add B and D, subtract C. If you want to find out C, add B and D, subtract A. That means I will write here C. A equals to B plus D minus C. B equals to A plus C minus D. C equals to B plus D minus A, and D equals to A plus C minus B. So like this we can write it. So understood now? So you might have followed this concept. Okay, it's clear? Raghavaya Boye, where are you from? Where are you from? Okay, next concept. For example, let us say A, let us say B, let us say C, with the vertices of triangle ABC. Vertices of triangle ABC. For example, this D be the midpoint of BC, E be the midpoint of AC, F be the midpoint of AB. That means D comma E comma F are midpoints of BC, CA and AB respectively. You give respectively. Suppose here is a one question. A vertices, A vertex, B vertex and C vertex have not been given. Instead of them, the midpoint of BC, midpoint of CA and midpoint of F are given. Then we need to find out A, we need to find out B and we need to find out C. Let us see how to find out now. You join these two. You join this one. You join these two. 1 minute. I will complete it. Okay. So now you join okay. Next you join D. Okay. So for example, this is the E point. E point. So now we need to find out A, B, C. Here very interesting that actually this A, E, D, F is a parallelogram. In the parallelogram already three vertices are known. A vertex you need to find out. A equals to, we can write F plus E minus D. Am I correct? So what is B? B equals to, we can write B equals to F plus D minus E. So now if you want to find out C, how to find out C? D plus E minus F. So in this way we can find out. In this way we can find out the vertices of the triangle if the midpoints of the sides of the triangle are given. Even this can be applied for the 2D geometry also. So I need not discuss the 2D geometry once again. This will be applicable for even 2D geometry itself also. Right? Okay, now D is equal to, we can write A plus C. So this is okay, A, C, B, D. D. Okay, 10th concept. So let us discuss 10th concept. The centroid of a tetrahedron whose vertices are A x1 y1 z1, B x2 y2 z2, C x3 y3 z3, and D x4 y4 and z4 is given by G equals to x1 plus x2 plus x3 plus x4 by 4. It will be useful for even vectors also. Yes, next equals to, we can write y1 plus y2 plus y3 plus y4 by 4, and next z1 plus z2 plus z3 plus z4 by 4, or we can write like this: G equals to A plus B plus C plus D plus A plus B plus C plus D by 4. So we can write A plus B plus C plus D equals to 4G. That means if three vertices of the tetrahedron given, even fourth vertex also we can find out. D equals to 4G times You remember now 4G era network, D equals to 4G minus of A plus B plus C. Okay. Now the most important points to be discussed. 11th point. Let P of x comma y comma z be any point on the space Ajay Khanna. So today actually I changed the timings because you know yesterday what happened to us. That's why actually I changed the timings. Just I will see. So otherwise, now the first option. For example, P lies on XY plane, because in a space we have different planes. Understood now? If P lies on XY plane, you remember Z coordinate is absent, so Z is equal to 0. So next, second point, P lies on YZ plane, so that means x equals to 0, x coordinate is 0. P lies on ZX plane, that implies y coordinate equals to 0. For example, fourth point, P lies on x-axis. P lies on x-axis means on x-axis y is equal to 0 and z is equal to 0. Both are 0. So next, fifth point, P lies on y-axis. These are very important points. So on y-axis actually x equals to 0 and z equals to 0. Sixth point, P lies on z-axis. So now x0 and y0. Yes, x0 and y0. Next, now let us move to the next concept now. Next concept. Are you following, all of you? Okay. Right. Prasanna, Narla Venkateshwarlu, Suma, right. Right. So now the 12th concept. What is the 12th concept means? First one, the distance from, that is perpendicular distance or distance. The distance from P x comma y comma z from xy plane is that means, first of all, projection of P x comma y comma z on xy plane, write down projection of, see the projection or foot of the perpendicular, you can say foot of the perpendicular from Px comma y comma z on xy plane. See, we know that on xy plane we have discussed. See, on xy plane z is equal to 0. So z is equal to 0 means the projection becomes, foot of the perpendicular becomes q. Here x comma y comma 0. That means now we need to find out distance from P to this Q point. That is the distance, required distance. So therefore, distance from Px comma y comma z from xy plane is equal to distance between x comma y comma z and x comma y comma 0. So that is equal to C, actually x minus x 0 square, y minus y 0 square, 0 minus z1 square, z square, root of z square is equal to z. You get mod z. So mod z. Understood now? In the similar manner, you can find out the distance from Px comma y comma z from yz plane and zx plane also. If you derive it, you will enjoy. Understood now? If I say, definitely will forget it. Understood? So now you try to derive. Before I am moving to the next concept. You need to derive it, and you check with my answers. All of you do like that. Next, second point. Second point need to be discussed under 12. The distance from Px comma y comma z or the distance of whatever it may be, no problem. To and fro also you can change. Distance of Px comma y comma z from yz plane. So first we need to discuss projection. This also concept, projection or foot of the perpendicular of Px comma y comma z on yz plane. See, on yz plane is equals to q. X is 0 comma y comma z. Therefore now distance of P from yz plane equal to, directly I will write, that will be what? Mod x. Understood? Mod x. Directly now I will write. Already we proved. This is second point. This is third point now. The distance of Px comma y comma z from zx plane is how much? Zx plane means mod y. Am I correct now? Mod y. Right. Mod y, mod x and mod z. Don't get any confusion. If you have any confusion, directly just you recapitulate and you need to recall foot of the perpendiculars. Understood now? Foot of the perpendiculars from Px comma y comma z to the respective planes. xy plane, yz plane and zx plane. Okay? Wonderful. Mod y. Yes, Govind. Right, no problem. You are trying. Now 13th concept we need to discuss. This is also very very important. The distance of px comma y comma z from x-axis is, so that means first of all let us write the foot of the perpendicular from p of x comma y comma z on x-axis. See, on x-axis is q. On x-axis actually x comma 0 comma 0. Am I correct now? Y coordinate, z coordinate both become 0. So now the distance, required distance of px comma y comma z from x-axis equal to distance between these 2 points. That means x minus x is 0, y minus 0 y square, z minus 0 whole square z square. That you get root of y square plus z square. Similarly, I will write directly distance of p x comma y comma z from y axis. You expect it? Y axis means actually here y is absent. Root of you will be getting x square plus z square. So distance of px comma y comma z from z axis. So that means you should z out. You will get here x square plus y square. Understood now? So this we can remember. Right. Today all the regular viewers are attended? No. Right. Thank you. Okay, yes sir. Okay, present. Sanjay Rani. Right. Give your attendance, all of you. Okay. Today I am discussing very interesting chapter. This will be useful for even vectors also. The same concept can be used for vectors. But share to your friends this one now. Though they are absent for the classes, just share them. You need to share it. Okay. Thank you. So now the 14th concept. Right. Thank you. Right. Okay. Might be. Right. The ratio in which p of x comma y comma z divides the line segment joining the points a of x1 comma y1 comma z1 yes Govind, actually yes, concept is very important. If you know the concept, you can do anything. Understood now? A x1 comma y1 and b x2 comma y2 is, so you can remember like this, x minus x1 by x2 minus x are equal to y minus y1 y2 minus y z minus z1 by z2 minus z. In 3 ways you can find out. So next, 15th point. The line segment joining the points a x1 comma y1 comma z1 and b x2 comma y2 comma z2 is divided by first one xy plane, not x-axis, xy plane. xy plane is, here we can write xy plane is divided by xy plane is, we can write minus z1 is to z2 minus z1 is to z2. Second point, yz plane is, that is minus x1 is to x2. Third point, zx plane is minus y1 is to y2. In the similar fashion, you can divide by x-axis also. X-axis means we can find out minus y1 is to y2. Y-axis means minus z1 is to z2. Z-axis means we can write minus y1 is to y2 or minus x1 is to x2. That also you can remember. Please refer it now. Next now, 16th point. The area of the triangle yes, exactly. The area of the triangle formed by origin O0, 0, 0, x1 y1 z1 b x2 comma y2 comma z2 is the area. Sir, I have one doubt. Minus m is to n and m is to minus n both are same. Yes, both are same. No doubt, both are same. Yes. Right. First, this can be done with the help of vectors. For example, the position vector of A radar, PV of A. PV of A is equal to OA. We can write this. We can write x1i plus y1j plus z1k. I already told you there is a interrelation between this 3D geometry and vectors. And position vector of B radar, that will be OB, equal to, we can write components of I, J, K are given, x2i plus y2j plus x3k. Now for example, OA, OB are the sides of the triangle, then area of the triangle is given by this vector area. Area of the triangle is given by of OA cross OB. This is vector area, but scalar area is mod. So that means next you need to find out OA cross OB. OA cross OB means determinant of, you write down here, I, J, K are the first row, where the second row are being components of the OA. Components of OA is x1, y1, z1. Row 3 is the actually here are being components of the second vector, x2, y2, z2. Expand by first row, that you will get actually y1 z minus y2 z1 of I minus j of x1 z2 minus x2 z1 plus k times, here see, x1 y2 minus x2 y1. So modulus we need to find out. That's why you will get of is equal to modulus of vector is given by square root of I component square plus z component square plus k component square. You get y1 z2 minus y2 z1 whole square plus x1 z2 minus x2 z1 whole square plus x1 y2 minus x2 y1 whole square. This is the formulation, that's all. You can use even vectors concept also to find out area of the triangle. Okay, so far I have discussed all the concepts. So tomorrow, okay, the class will be up to only 5:30 actually, 4:30 to 5:30. Enough today because I have discussed a lot of concept. One day the concept, tomorrow we shall go for the problems in detail. Because this is the first episode, it will be continued now. You remember, it will be continued. That means to be continued. To be continued. Right. Bye. See you. Because don't worry, vectors also the cross product we can find out like this. So even directly we can apply the determinant also. By applying determinant also you will get it now. Understood now? Right. Thank you one and all. Bye bye. See you. Have a nice day. So tomorrow we will meet you in integration chapter. That will be continued. Slowly we will go. Because the integration is very important part. That's why we need to concentrate more. Understood now? Thank you all of you. Bye bye. So now all of you share to your friends, because they might not be known about our classes today. Right. Thank you one and all. See you.